I'm really delighted to introduce the panelists of this session. Melanie, whose PhD work when she was at Cambridge really formed the basis of what we're going to hear about, and she's now a data scientist at Growing Underground. Ruchi, who is one of my colleagues at Cambridge and one of the group leaders in the data-centric engineering program at the Alan Turing Institute. And Rich, who is the co-founder of Zero Carbon Farms, and he is the farmer-in-chief of Growing Underground. And Jacob, who is the head of research and development and data at Growing Underground. Now, before we start the session, we're going to have a short video which will give some background into what we're going to be hearing from our panelists just now.
We saw issues in the world, issues around climate change, the way we produce food. We need to look at the ways of doing things differently and intensifying yields and growing produce closer to the point of consumption and growing more within a smaller space. Our first site is Growing Underground, which is 33 metres underneath the streets of Clapham, London, in a World War II air raid shelter. We grow 70 tonnes of produce a year from this site.
We also use 100% renewable energy that uses about 70% less water than traditional growing methods.
We don't use any artificial herbicides or pesticides. We also don't deploy GMO crops. And so effectively what we're doing is we're creating an artificial environment for a very natural product.
So what we do is we take a few different crops and we mix them together for these really unique flavor profiles.
The flavours are really intense because it's compacted into a small plant, highly nutritious, some of them up to 90 times more nutritional value than their fully grown counterparts.
What we're doing is really making a difference. Urban centres are going to rely on controlled environment farms for their fresh produce. You know, we need solutions, and I'm just so thrilled that I get to be a part of that.
Seeing Michel Roux Jr. from Le Gavroche in London as a customer of Growing Underground is a real hallmark of the quality of the produce here. But let me ask Ruchi perhaps to start off by introducing us to the way in which the partnership with Growing Underground developed and the technology behind the digital twin or twinning that was developed. Ruchi.
Yes, thanks, Mark. So I have to start by saying that this has been probably one of the longest, richest, and most fruitful partnership that has thrived since the early days in the farm, when we started working with them back in 2015. At that time, the farm, the first time I noticed it, it was featured in a food magazine as a small startup of 30 square meters of some experiments on growing microsalads. And I noticed them at that time because we were interested in scientifically estimating the heat, CO2, humidity relationships between plants and environment in control spaces, inside buildings, for example. And of course, we went and met them. And they were absolutely welcoming from the get-go. And they gave us the opportunity to try to track, monitor relationships between the plants and the environment. And they were supportive of letting us use the farm environment, even though at that time they had other priorities, such as expanding the farm and more logistical challenges to get through. And I thought at that time that this will be a short project. And this is, now we are 2021 and we are still working on it. So it's been a really humbling experience to try and go through the range of challenges along the way some of which they had to do with how you get data 33 meters underground, initially without a Wi-Fi network and without an elevator and without, power connections. And some have to do with monitoring in a wet environment where people move around, processes move around. So it actually, the pivotal moment came when Melanie, who you will hear from next, when she took this on board as her PhD and her life project for some years. And so some of the challenges that Melanie will talk about more, which is, how we tackle the challenges of getting the right sensors in the right places, how to connect them up, how to stream the data, figure out where they should be located so they measure something meaningful, and at the same time, they're not getting into people's way because they need to go through the business of farming. It was also amazing and pivotal to have the Center for Smart Infrastructure and Construction at Cambridge to help us out with this issue surrounding hardware, data streaming, etc. So a lot of talent went into the whole project. And as I had mentioned, that on a scientific level, we were interested in generating data and using it to tune our understanding of evapotranspiration in enclosed spaces. But at the same time, what really changed the game on this is that we started to generate practical value from the data on a weekly basis or day-to-day basis. And we did that by using the data and translating it into information to assess conditions under which the microsalads were more happy. So how many hours of light you need for the plants to thrive, potential overheating issues, ventilation, under-ventilation, over-ventilation, etc. And that was kind of the game changer that made Growing Underground equal partners and equally committed into the data as we were. So it was no longer just a scientific exercise. It became of practical value to have around. And then the second step change came around 2 years ago when data-centric engineering program welcomed us, and we upped the game there and started to work with Turing software research engineers and data scientists to digitally twin the farm. And what practically that means is that there are models and data coexisting on a digital platform. And so what that changes is that as new data comes in, we can update our models and provide feedback that can be used to tune the farm operations. And of course, I don't need to mention through all the issues that you've been hearing throughout the day today, that there are many non-trivial aspects to it, owing to all the reasons that you've been hearing about. And there's still so much to achieve. There's still, in fact, we are now looking forward to another 2-3 years of research on how to expand the digital twin to cover, let's say, supply chains, to cover nutrients and crop growth, etc. So I'll let Melanie now describe some of her research.
Thanks, Ruchi. I think this is a good time to show the video of the digital twin, which just overviews a bit what we try to achieve. So as Ruchi said, we basically, when I arrived at my PhD, just put lots of sensors and tried to analyze the relationship between temperature, humidity, and link that to crop yield. And so here you can see different sensors placed in the farm, and how we're using this twin to not only just upload our data into a database, but also be able to interact with it, such as see which sensors are online, which sensors are not, and then link, not only just have the data, but link that to models. So for different models we've been developing over the time have been data-centric models where we try and forecast temperatures in the farm based on data, so that when events change in the farm, such as the lights don't turn on or a different operating regime happens, we don't have to prescribe what's going on to be able to predict the temperatures. And other models where actually we do prescribe everything and we can calibrate automatically what's going on, and have the best virtual representation of the farm on this digital twin. So what we're trying to do really is just automate things that you could learn from the data by analyzing it and put that online. And we don't have much time, but basically there's lots of challenges from, as you said, just the hardware itself, connecting sensors with Wi-Fi or radio signals underground, to something goes wrong, the power goes off. How do you fill in the missing data when you're trying to do something in real time? To just British summertime, everything. If we have if you base model on seasonal patterns, and then every 6 months the seasonal pattern shifts by an hour, but not the perceived pattern, it can cause lots of problems. So these are the kind of real life effects problems. But you could feel free to email us if you want to find out more. I think it's time to hear from Richard about what the partnership was like on the commercial side.
Thanks, Val. So really, the business actually started in 2012, and we started doing trials in the space. Around sort of after those trials for a couple of years, around 2014, we launched a crowdfunding campaign, which really got picked up by the press and was, a big story worldwide. And we got a huge amount of press, huge amount of coverage, investors from all over the world. We actually ended up raising £650,000 in the first round to expand and build the farm that we have today. This brought a lot of attention, and that's where we originally met with Ruchi, approached us, and Rebecca from Cambridge. We're extremely honoured to have such a prestigious university, interested in what we were doing. In the early days, we thought that, we always joke that one day somebody's going to tell us that we can't do this for whatever reason it was, and that never happened, and it kept building, and here we are still today. So we always knew about the importance of data, but what I think we felt and we didn't really understand at the time was the effect of how the design of the farm, how that affected the environment, the convection of heat from different materials, and the LEDs. And then I think most importantly, the extent of transpiration of crops and the effect on the environment. And that's really where, Richie and Mel and the team have really brought this an amazing understanding for, and really helped with the early days of building that farm and making sure, we could have put equipment in that really wouldn't have worked. So it was very good to get that feedback and understanding from them. The tunnel's quite interesting. The tunnel we grow in is actually on an angle. It's sort of slightly, so the front part of it is cooler because we get cool air coming from outside that's drawn down from the outside. The middle is quite stable and at the middle temperature, and then you've got a very a hotter but more humid end to it. This has really helped us because we've got data on all the crops we put into the different areas over the last 6-7 years. We've really realized that we've got different data on the day temperatures, the night temperatures, the airflows, the CO2 levels, as well as things like pH and nutrient levels in the water. So we've got a huge amount of data now collected from, and that really is thanks to Cambridge and the team for that. Now we are, once we actually launched the farm in 2015, we actually took an investment from a company called G's Fresh, a large agricultural supplier of fresh produce into the UK, and they are European wide. They, as well as helping us with technical standards, they helped us into, we were already supplying into food service in London. They opened the doors to retailers. We started to supply people like Ocado, Marks and Spencer's, Waitrose, Tesco's. The farm is full now. We've just finished a 5 million raise, and we're building a new farm in North London. And that's going to be a very automated, controlled environment, and using the data and all the knowledge we've learned from Clapham, and we will continue to run Clapham as well at the same time. So I think that's it from me. I'll pass you to Jacob.
Thanks, Rich. I'd like to elaborate a little bit on the use cases that we have for data and the information we can derive from data in the farm. Essentially, there's 3 different use cases. It's simply the monitoring of the farm environment, of the water quality, of the crop performance, etc. Then it's the analysis of the independent variables such as temperature, other environmental factors, etc., on crop performance, on yield, on the specification of the crop. And then finally, it's prediction. And that's prediction of, for example, how would a particular crop perform in terms of yield if we know that a specific variable will change over the next month. So if we have seasonal changes, for example, if we have a heat wave and we can't counteract that with our environmental control system, then what does that do to our crop performance? And based on that, what do we have to do in order to fulfill our orders? What can we do in order to get rid of any surplus and derive more revenue. But also importantly, on the prediction side, how would a specific space that is a candidate for a vertical farm behave if you put in 4,000 square meters of growing space? If you have millions of plants all growing at the same time, transpirating, water evaporating, how would that space heat up? How humid would it be? And as a consequence, what kind of equipment would you need to counteract that? And why is that important? It's tremendously important, especially the latter part, because vertical farm is a fairly capital-intensive undertaking. You need HVAC systems, you need lighting systems, you need decontamination systems. And underinvesting in that is obviously dangerous, because then you end up with equipment that doesn't do the job. Overinvesting is just as difficult, because obviously you're then spending a lot more money than you actually need to, not just on the capital stage, but also then on the operational expense side of things. And the more we can really pinpoint and predict how these spaces behave, the more we can fine-tune effectively our financial models and our planning, and the more effective these farms basically become in terms of capital expenditure, but also in terms of operating them. And on the commercial side, financially, this is important to us, but I think in the bigger picture, in terms of climate change, in terms of finding alternatives to food production, it's tremendously important to make sure that these farms can become a viable part of the solution to how food is produced in the future. In terms of how we do these things, so monitoring is relatively trivial. It's basically collecting the data, which I guess actually is not that trivial. Listened to Mel and Ruchi before. But then storing it, visualizing it is relatively straightforward. It just requires showing the data in a way that a non-technical person can make sense of it. The analysis is really just an exercise of applying some statistical methods like multivariate regressions, things like that, to find out what is the correlation between temperature changes and crop performance. And then prediction is really where it becomes really complicated, where you require fairly sophisticated models that we really are only able to utilize as a result of this partnership with Cambridge University, with Mel, Ruchi, and Rebecca's help. We would have never been able to do this at this stage of the business without this partnership. And so we're tremendously grateful and happy that the partnership exists and that it continues into the future. And just as a final note, what are we looking for in the future? So really the challenge we face is that there's a lot more data to be collected. So we have controllers that operate all of these systems, the HVAC, the irrigation system, etc. They all log data, they record data. We have machinery like sowing and harvesting machines that log data, and really any piece of hardware that generates any kind of data sits in our farm, and ideally we'd like to bring all of that data into a unified platform so we can then use it to do even more analysis, do even more prediction. And I mean, really the possibilities are endless, but the challenge is that all of these pieces of hardware don't talk to each other. They use different communication protocols, and it's very difficult to bring everything into one place. That's the challenge we face for the next farm, and we're very determined to overcome that. But once we've overcome it, I think we'll end up with a tremendously powerful data set that we can utilize to make the farm more efficient, to also help research, etc., etc. So the future is really exciting, and we're looking forward to continue this partnership and also building new ones to find out what we can do.
Jacob, Rich, Ruchi and Melanie, thank you very much for describing this fantastic, really inspiring project and the way the partnership is addressing some of the really serious issues that we're facing today. So thank you all.